Why, hello there. We're going to go ahead and talk about the Lesson 8.3 homework. Number 1, find the geometric mean between each pair of numbers. Okay, so I'm looking at 5 and 20. I'm going to call this A. I'm going to call this B. Remember, the setup is essentially 5 over x equals x over 20. You're going to cross multiply. That is not me cross multiplying, that's me erasing. Cross multiply, so x times x is x squared, and then we have 5 times 20. Well, 5 times 20 is going to give you a perfect square. So if I take the square root, x is 10, and 10 is the geometric mean between 5 and 20. And then maybe you'll get something like this on a quiz or an assessment. If you have to find the geometric mean between a fraction, let's say 1/6 and 192. Well, that's essentially saying, okay, it's x equals the square root of 1/6 times 192, and I have a fraction and a whole number, so I can go ahead and multiply those. So 1/6 of 192 is the square root of 32. So x is equal to the square root of 16 times 2, so x is equal to 4 root 2. Okay, something like that you may get. I'm going to skip number 4 to move on to that. Number 7. Corey wants to estimate the height of the statue of Stephen F. Austin in Angleton, Texas. He stands approximately 19.3 feet away from the statue, so that his line of vision to the top of the base, to the top and base of the statue form a right angle, as shown in the diagram. About how tall is the statue? Okay, so we need to figure out how long the statue here is. So if this here is 19.3, then that means that the altitude is 19.3. And if this is Corey, standing right here, then this is how long this segment here is. So we're going to call that 5 feet. Okay, so let me go ahead and label my figure. Obviously, this is the hypotenuse. Oh, sorry, that's way too long. This is the hypotenuse. And then this is segment 1. This is segment 2. That's leg 1, leg 2, and then this is the altitude. Okay, so just by looking at this triangle, let me go ahead and write HL1, L1, S1, and then we have HL2, L2, S2, and then segment 1, altitude, altitude, segment 2. Okay, so segment 1, we don't even know what segment 1 is, and that is actually a requirement that we have to figure out what segment 1 is, because if we know that this here is 5, whatever this is, that's going to help us figure out our hypotenuse. So segment 1, we're going to call that x. Okay, so let me see. So the hypotenuse is, well, 5 plus x, so that's the hypotenuse. So I'm going to put x plus 5 here. And who knows if I'm going to use all of these things, but I'm trying to figure out which one works best. Okay, so what's leg 1? Leg 1, we don't even know what leg 1 is, so I don't really think we're going to use that at all. And then the hypotenuse, that's again x plus 5. And then leg 2, do we know what leg 2 is? No, we don't. There's no thing here, and we don't even need to know what leg 2 is anyway, so we don't need that at all. So we have SAAS. So segment 1 is x. The altitude is 19.3. And then segment 2 is 5. So look at that, we have x, 19.3, 19.3, and 5, so that's great. So I can go ahead and create my proportion. And then I'm going to cross multiply, so x times 5 is 5x, and that is 19.3 times 19.3, which I'm going to say it's 19.3 squared. So then I'm going to use my calculator, because I'm going to solve for x. So it's 19.3 squared divided by 5, and that's going to give me 74.498. So x is 74.498, and to some of y'all that would be approximately 75, right? So I could say that if I know what x is, which is 74.498, or approximately 75, yes, so 75 plus 5 is, that's approximately 80, or if we just stuck with our original answer, that would be, 74.498 plus 5, that's 79.498. Okay, so I could accept, I can also accept 79.5 as well. So 79.5 or 79.498 or just 80, those answers are acceptable. And the unit, that would be feet. So everything would be in feet here. Okay, there you go. Okay, so find x, y, and z. I got a lot of questions about this one here because the hypotenuse is just strictly y, and we have this segment here. So the first thing that you have to do is number one, label. We know that the hypotenuse is across from the 90-degree angle. So this is the hypotenuse. And then this part plus this part will create the hypotenuse. So segment 1, segment 2, this is leg 1, this is leg 2, and then this is the altitude. Let me go ahead and figure out what segment 2 here is, because we know that segment 1 is 6 and the hypotenuse is just h. Or the hypotenuse is just y. So you have to understand that rule, part plus part is equal to a whole. Well, part plus part is equal to a whole. That's using the segment addition postulate. We know one of our parts is 6, and that other part is our unknown. That's segment 2. We're going to call that segment 2. Is equal to the whole thing, which we just call y. So if I were to solve for segment 2, I'm going to subtract both sides by 6. I get segment 2 is equal to y minus 6. So I will put y minus 6 for segment 2. And that makes sense because, well, 6 plus y minus 6 is just y. The 6's cancel out. So you should be left with y. So let's go ahead and use our organizer. So I write S1 altitude, altitude S2, and then HL1, L1, S1, and then HL2, L2, S2. The segment 1 is 6, the altitude is 17, and then segment 2 is y minus 6. The hypotenuse is y, leg 1 is x, segment 1 is 6, hypotenuse again is y minus 6, leg 2 is z, and then segment 2 is y minus, no, just kidding. So the hypotenuse is y, and then segment 2 is y minus 6, okay? Alright, so I'm just going to look at my organizer here, and then you're going to say, okay, which one can I work with first? Well, I can't work with this one because there are two variables here, right? We have a y, and then we have a z. So you can't use this first. we're going to get back to this one later. This one's a lot easier because if I look at this one, you're going to have to use the distributive property. So, actually no, I'm just kidding. You can't use this one because we have two variables. We have a y and an x here, so there's no way you can work with that one yet. So, really, actually, we're going to be working with segment 1, altitude, segment 2, so that's SAAS. We're going to be using that one first. My apologies that I didn't see the two variables there. So we will do 6 over 17 equals 17 over y minus 6. You're going to cross multiply. So you have 6 times y minus 6, or sorry, 6 times the quantity y minus 6. You're going to distribute the 6 to each term. So 6y minus 36 is equal to 17 times 17. That's 289. So then I have 6y equals 325. And then 325 divided by 6 is 51.1666666 blah blah blah. I'm just going to say y equals 54.2. I'm going to round that to the nearest tenth. So now that I know what y is, I can go ahead and replace my hypotenuse with 54.2. Okay, so I have y, that's good. Let me go ahead and solve for x. So I do 54.2 over x equals x over 6. That's x squared equals 6 times 54.2. That is 325.2. Take the square root. And then that's 18.033, or just 18. Okay? So now, let me go ahead and figure out what z is. So we already know what y is. That's 54.2. And then we don't know what z is. That's what we're trying to solve for. And then we have 54.2 minus 6. And that's 48.2. So I have 54.2 over z equals z over 48.2. So z squared equals 54.2 times 48.2. So you're not going to be simplifying radicals because you're dealing with decimals. Simplifying a decimal is very, very difficult, so I'm not going to make y'all do that. We're just going to take the square root of everything, and we're going to put everything in our calculator. So 54, so the square root of, so if I'm taking the square root on both sides, I have the square root of 54.2 times 48.2, and that is z equals 51.1. And there you have it. And real quickly, let's see, 5 root 13, I'm just looking at the key, is that 18? Okay, good. So, I don't recommend that you, simplify the radical here. I know on the key it says 5 root 13, just give me 18 and that will work. Again, that's just, I don't want you to go through the hassle of, simplifying a radical where the radicand contains a decimal. That's just, a little difficult and hard to explain. Okay. So 21, 22 you can do on your own. And then it says find the geometric mean between the two numbers. Okay, we went over an example like this already, so 26 is fine. But 27 is a little weird because you're finding the geometric mean where you're already taking the square root of a square root, if that makes sense. So let me just go ahead and, alright, so we have 3 root 2 over 7 all over x is equal to x over 5 root 2 all over 7. Okay, so you know that x times x is x squared. And then here, you're going to have to multiply this and that. So it's 3 root 2 all over 7 times 5 root 2 all over 7. Okay? You're going to take the square root on both sides. So you know that these two things will cancel out, so x is on the left-hand side. And then we have the square root of a fraction times a fraction. Let's ignore the fraction for now. Sorry, not the fraction. Let's ignore the square root for now, and then look at these two fractions. When we're multiplying fractions, obviously we don't, cross multiply there because there's no equal sign involved. But when you're multiplying fractions, you have to multiply across. So I'm gonna focus on the bottoms. So focus on the bottom. So we have 7 times 7, that's 49. And then I'm going to multiply the coefficient to the coefficient, that's 15, right? So 3 times 5 is 15. And I have root 2 times root 2. So if root 2 times itself, that's just going to be whatever is inside of the radical sign. So that's 15 times 2. Simplify that. The square root of 30 over 49, and you have to know your radical rules. The square root of 30 over 49 is essentially the square root of 30 over the square root of 49. We know what the square root of 49 is, that's 7, and then the square root of 30, well, let me go ahead and see if I can simplify that. No, I cannot, because 5 doesn't have a pair, 2 doesn't have a pair, 3 doesn't have a pair, so we're going to leave square root of 30 as the top. It's going to remain unchanged. So that's your answer, square root of 30 over 7. Okay? And then for 35, make sure that when you're doing this, you figure out that you understand that the hypotenuse is 25 plus t, because you are essentially adding two things. Actually, do you really need to know segment 1, altitude, segment 2? Oh, I don't think you really need to do this. Let me go ahead and do this problem real quick. So this is segment 1, segment 2. This is the altitude. That's 24 over 12 equals 12 over t plus 1. Okay, so that's 12 times 12. That's 144 equals 24t plus 25. Okay, so basically this, you don't really need to use hills at all. This is more of a SAAS type of problem here. Okay, and then you minus the 25 on both sides. What's 144 minus 25? I don't have my physical calculator with me, so I'm going to have to use my calculate 84. Okay, so that's 100, oops. That's 119 equals 24t. So t equals 4.96. So it's 4.96, or you can approximately say that's 5. Okay. Alrighty. Ooh, this problem is a little weird. So Zachary wants to estimate the height of a cliff. He stands 15 feet away from the base of the cliff. If his eye level is at 5.5 feet, which of the following is closest to the height of the cliff? Okay, so if we look really, really closely, I know it's not obvious, especially when your paper looks all, blurry and stuff. I don't know if it's blurry on your side. I think it was blurry, but I didn't really I couldn't recognize it until now. But look at this. If we ignore this stuff here, but if we focus on the stuff that I'm about to highlight, that there is a right triangle. curvy segment there. Alright, this is what I can just draw right now. Okay, so I'm basically redrawing this, and we have our little altitude here. It's not perfect, but whatever, right? Okay, I'm just gonna redraw this. Alright, so our altitude here is 15, so I'm gonna put 15 there. And then this segment here is 5.5 feet. And I need to know how long the cliff is, so we're gonna call that X. And then this is the right angle, and then this is the little right angle that I'm supposed to draw there as well. Okay, so this is basically a right triangle proportion. That's awesome. Let's label our figure. This is segment 1, segment 2. This is the altitude. Okay, so it's SAAS. It looks like we're going to be dealing with SAAS here. So I write X over 15 equals 15 over 5.5, cross multiply. So that's 225 equals, you know, X times 5.5 is 5.5X. So X is equal to, there we go. That's, 45. So X is equal to 45, and I want to know how long is this cliff, right? So if this is 45 here, and there's this 5.5 feet, well, that's essentially 45 plus 5.5 feet. So 45.5 plus 5.5 is, what am I doing? 45 plus 5.5, that is 50.5. And then this is a little weird because it says which of the following is closest to the height of the cliff, and y'all, we don't even have multiple choice options here, so that is a little strange. Let me see if I'm doing something wrong. That's 200. Oh, sorry. You know what I did wrong? I put 225 divided by 5 instead of 225 divided by 5.5. I was wondering what's going on here. I was like, that's not right. Okay, so X is equal to 40.9. So X equals 40, or not X equals. Our cliff, the height of the cliff is 40.9 plus 5.5. So that should give you 46.4 feet. There you go. This is your answer. Okay. And then, okay, now that we figure out 56, we can figure out what 57 is. In the figure, segment AD is perpendicular to segment BC. Okay, so AD is perpendicular to BC, so there's a right angle there. And AB is perpendicular to AC, so there's a right angle there. Okay, so it's basically, this figure is just like this, right? So we're dealing with right triangle proportions. What is BC? So what is BC? Okay. So we have BD plus DC. That's gonna give you BC. And I don't know. Maybe I should put an X here just in case, because why not? So let's go ahead and label our figure. So we have the hypotenuse. This is segment 1. This is segment 2. This is the altitude. That's leg 1. That's leg 2. So, okay, so what should I do now? I'm gonna write HL1, L1, S1. I'll put HL2, L2, S2, and then segment 1, altitude, altitude, segment 2. Okay, so the hypotenuse is 5 plus X, right? Because part plus part equals whole, so 5 plus X. Leg 1 is 10. and then segment 1 is 5. Okay, so this one looks really, really nice because we're dealing with just one variable. And if I were to look at, you know, hills with a subnotation 2, there's really nothing there, so I don't need to use hills 2. Let's see SAAS real fast. Okay, so we have segment 1, and then there's the altitude. We don't even know what the altitude is, so we don't need that anymore. So basically, hills with the subnotation 1 is we're going to be using that. So it's 5 plus x over 10 equals 10 over 5. Cross multiply, so 100 equals 25 plus 5x. So 75 equals 5x, so x equals, is that 15? Oh, yep, that should be 15. Okay, so x is equal to 15, and I want to know how long BC is, right? How long is BC? Well, it's 5 plus 15, so the measure of BC is not 50, it's actually 20. And there you go. Oh, what is that? So BC is 20. Alright, I'm done.